Hey there, curious person. Welcome to the Zoo workshop for the KittyCAD Design API, specifically for JavaScript. I'm going to quickly take you through how to go from absolutely no code into a fully working web application. We're going to use next.js, and we're going to directly hit the KittyCAD Design API instead of using an SDK, because in this instance, it's actually more flexible and easier to do that. It's kind of a proof that the API is developer first and developer friendly. So we're gonna get right into it. Strap in, because we go very fast here. Okay, so starting off fast here, we're gonna go to the Next.js website. We're gonna copy their little command line tool to create a project. We're gonna paste that in. We are gonna quickly select no for everything, especially since it's just a JavaScript web app for the purpose of the demo. We see things have installed there. It's done. We are now changing the directory into the directory that it had created. We're gonna install a couple of packages. The 3 package for 3JS to show our object files that we're going to get through the WebSocket, the vsin for the binary JSON, and finally the WS for the WebSocket support on the Node.js side. After that, we're going to go into the page.js. We're going to fast forward me deleting all the boilerplate that it has, and then we're going to have a little title that says Giga Furnishing Corporation Coaster Dinner 9001. So today we are working for Giga Furnishing Corporation, and this is the product generator that we are making for them. And we have a little coaster generator component that we're going to create. So let's create the folder, and then let's create a file. We're going to go in there and type some more React boilerplate code that we all love so very much. And then we're going to have a diameter, coaster diameter parameter that you just can adjust. So we range from 1 to 10. I'm going to type the useState React hook that we need to track that diameter. Diameter, set diameter. We're going to use a default value of 1. Make sure that we update the value as it changes on the range slider. And then we're going to have a scene component. So that scene component is where 3JS will live. And we will get to that in a second. Before we do, we're going to have a button. So this button will drive the creation of that component, that scene component, whenever it's clicked, which we'll call the go function. And the go function will set a is ready Boolean to true. And then the scene component will have a diameter property, and that will change as the user slides the slider. So we create the scene component. Scene component's created. Blah 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 blah. More boilerplate. Here we use a use effect. This is a very large use effect component, which keeps track of a canvas reference. The canvas reference we will have to pass off to 3JS. The use effect will reinitialize 3JS at any time the property diameter changes or the canvas element changes. Now we're going to look up how to load a GLTF, but very shortly I realized that I'm actually looking how to load a object file. The code for both of these is very, very similar. The main difference is this has the GLTF loader instead of the OBJ loader. And there we go. Obj loader. The code itself is also slightly smaller than the GLTF loader. We just paste that in. Now we also copy the 3JS code, initialization code. We paste that in after we make sure that the canvas has a not null reference or falsy reference. Here I'm just reminding myself that the GLTF is actually the better model format, and also to tell you guys that if you can, load the GLTF. Again, we're just going with object for the simplicity's sake of this demo. Here we pass off the canvas reference to the rest of the code. Here I am deleting a checkerboard plane that is used in the scene. But what's really important is what I'm about to show you next is this is a URL. So Three.js is able to load models from a remote source. In our case, we're going to load it from our own web application from the API generate endpoint. And we're going to pass in the diameter as a query string parameter, like we mentioned earlier. Finally, we're going to test to see where we're at. It's been a minute since we actually tested the code that we've been writing. As we can see, there's a build error. That's because we're missing the use client directive that next.js requires. And then you're going to see me fail for a little bit trying to get the page loading into a good state. Had I used TypeScript, I would have not hit this. All right. Where are we at? So you can see now the Three.js scene loads, but we have a 404, which makes sense because we have not defined the route yet. So let's go define that route. We're going to go create a API directory, and then we're going to go create another directory called generate, and then within that we have the route.js. And then in route.js we're going to set up the get handler, request handler. Very straightforward. And this is where the fun really begins, and we start to interface with Zoo's KittyCAD Design API directly. So here, our get request handler is going to await on a promise, which will eventually have our GLTF code. And what it does, it will return that to the response. We go into our API documentation for modeling, and we can see open a WebSocket, which accepts modeling commands. That's exactly where we're at. You may see this documentation in the SDK that we support TypeScript, but I do not recommend it. We are going to go with direct raw API commands, simply because it is easier at this time of recording. And thus is the purpose of this video. We are going to use the WebSocket class from the WS package and the bson object from the bson package. And then we're going to connect to the WebSocket. As you probably saw earlier, it's HTTPS. This is going to be a WSS, not WS. This is a secure WebSocket connection. And then there are some query string parameters that we have to set. So post effect must be SSAO. Again, at time of recording, it is just a more stable option to pick. Most commands will still work, but you may find yourself in an odd state if you select something else. Unlock frame rate is equal to true. Video res and width and height should be set to something that is divisible by 4. Otherwise, the engine is not happy. And that's pretty much it. You could also set WebRTC to false, or you can check out our Zoo Design Studio or the Cookie Cutter project to see how to connect to the WebRTC stream. So here we listen for a message. The message just comes in bytes. Pretty sure it is a buffer already, so this is a redundant buffer.from. We try to parse it as a JSON, and if that fails, it is probably a binary JSON structure. It is not the safest thing to do. There are probably more robust ways to check for that. But again, this is a demo, so we're just trying to get to the goal as soon as possible. So we're going to go check out to see what happens when we connect to the WebSocket. If you're following along, you should also get this error that we're about to hit. It is an authentication error. So we need to get an API key, no problem. We're going to go sign in, single sign on. We're going to sign on through Google, the good old Goog. Access keys, we're going to have a API token generated. We're going to copy that token. We're going to go paste that in through a environment variable. Actually, yes. We are going to authenticate as soon as the WebSocket opens. This uses a mechanism very, very similar to regular HTTP authorization. Here I write a small little helper send function, so I don't have to type that everywhere. And as you see, we have an object with type headers, and then we're going to have the familiar authorization header with the bearer string inside of it, using the process.env.kitty API token. And then you're going to see my API token. Do not use this API token. It does not work in the slightest. So do not complain if you try to use that and it does not work. So again, we see what happens. We want to verify that we actually authenticated. We did. That is the primary signal that we have authenticated with the remote end. Modeling session data. So also a data.success is true. So if it's false, we are just going to bail out and ignore everything. Again, not recommended. You should report that in some way through your endpoint. Otherwise, if the response type is a modeling session data, we will then fire off our modeling commands. Now here I was going to have a separate fire modeling commands function, but I decided not to. I decided to inline it instead. And I'm also going to show you a little trick coming up. So we're going to go to the documentation very briefly, and it becomes quite obvious that it is quite difficult to piece together what commands you need right off the bat. As you'll see, modeling command request, commands, and then the whole list of commands. There's just a whole waterfall of them here. So a little cheat you can do is you can go to the Zoo Design Studio and you can model pretty much the thing that you want to generate. And then you can look at the network request and pull out exactly what you need. So here I am sketching our coaster, very straightforward. And then I'm going to go look in the network tab of the developer tools in Chrome. There we go. I refresh just so it's easier to find the commands. Then I'm searching for a modeling command request batch or batch request. And then I'm looking for a batch request with my arc call inside of it, which creates the circle. There it is, extend path, segment type. We got all that. Perfect. We just copy the value and we can paste that right into Ascend. And this works. We see a bunch of UUIDs. Normal usage of this would ask you to generate actual unique IDs. Here, we turn this into we use our parameter that is coming in through our query string. Now, we originally wrote diameter. During the recording of this, I forgot to divide this by 2 because it's a radius. So as long as you understand this as you're watching, that's good. Diameter is not a radius. We multiply it by 10 because the final result otherwise does not look so great in 3JS. And then I'm just verifying that the structure is what we want. And then we go and we fire it off to see what the response is to this one. Again, just one step at a time, just inching our way forward. So modeling batch is the response that you get from the command, modeling command batch request. And when we get our modeling batch, we say, okay, great, you've done all of our modeling. Let's now export this, right? So we're going to export. And once again, we're going to go cheat. We're going to use the Zoo Design Studio to export the model into an object file. And we're going to just look at the network message going out. and we can see there it is. Beautiful. There's the export. We're going to copy the value. We're going to go back to the application, slap that in, hit run again, and there will be some good news on the other side. I'm not sure why I decided to stare at the pings there for a second, but I did. Once again, some basic formatting. Format that. Make it beautiful. Then we're going to run it. Actually, before we run it, in this case, we want to see we got the binary JSON, because this is where the API uses that, and it's always during export. It's a more efficient protocol to use. So we got it. Fantastic. That means the JSON.parse failed. And then we're going to peek inside what that deserialized binary JSON had. So we can continue on to the next step of actually exporting the object data. So once again, console.log, very straightforward. Run the application, hit let's go, refresh, same old song and dance. Boom, we're back. There we go. Response type is export, data files array. And from previous experience, I know that inside of that files array, there is a .contents that we can return. And that will have our object data. Very straightforward. We resolve the promise that we originally wrapped all of this around, and our endpoint will have the the object data. I'm remembering now that I had wrote GLTF at the very beginning. It is wrong. It is object. And bada boom, bada bing. We have a coaster, and I'm sure that Giga Furnishing Corporation is very happy now that they have a coaster generator for various needs and uses. So we're at the end. I hope that wasn't too bad. We were able to generate models in the end, which was the ultimate goal. You should be able to now create other web services which do similar tasks. We also learned that the Zoo Design Studio is a really useful tool to learn how to compose all these modeling commands. As we saw, there's probably well over 100, and to figure out how they all connect together, it can take a lot of work. So I really recommend you using that as a source of knowledge. I also recommend that you check out our GitHub repositories. They also have a lot of information, especially because the Zoo Design Studio is completely open source. You can look at that. There's also a cookie cutter example that you can look at. It's very self-contained. That's all I really have to say. I look forward to seeing what people come up with. We all do. You can share your creations on social media with us or on our forum. And I hope you have a fantastic day, and I'll see you around.